We now discuss the solution of a problem from the section complex numbers. The problem is related to find the number of lattice points in the annulus in the complex plane for a given question. This question has appeared in the joint entrance examination main held on 28th June 2022 in the first shift. The given question is the number of elements in the set consisting of Z is equal to A plus IB, where AB belongs to the set of integers, that is Z, and 1 less than modulus of Z minus 3 plus 2I less than 4 is required to find the number of elements in this set. The set is given as the set consisting of Z is equal to A plus IB, where A and B are integers and satisfying 1 less than modulus of Z minus 3 plus 2I less than 4. We now discuss the solution of the problem in detail. Consider capital A is equal to the set consisting of Z belongs to C, the set of complex numbers, such that 1 less than modulus of Z minus 3 plus 2I less than 4. Z is a complex numbers, means its representation is x plus iy. We take it as the set consisting of Z is equal to x plus iy belongs to C, satisfying 1 less than, and now this 1 less than modulus of Z minus 3 1 less than, this will be x minus 3 whole square plus y plus 2 whole square less than 4 square. So what is this one? What is this one? This is the region between two concentric circles, and the region between two concentric circles is called annulus in the complex plane in the complex analysis. Right. So this region between two concentric circles is called annulus in the complex plane. And what are the two circles? The first circle is C1, x minus 3 whole square plus y plus 2 whole square is equal to 1. That is the smaller circle with the center 3, minus 2 and the radius 1. And the second circle is a bigger circle with the same center as above, and the radius is 4. So it is shown here in the picture, and in this diagram, the outside this red circle and inside the green circle, that is the annulus, that is the region between the two concentric circles. Agreed. So that is the annulus, but what you have to find out is all those complex numbers whose components are integers, whose components of integers that lie in this annulus. So now required to find n of S. What is S? Where S is the set of all ordered pairs A comma B, where A and B are integers such that 1 less than A minus 3 whole square plus B plus 2 whole square is less than 4 square. So this the same thing is now translated into this one. So A plus IB is written as the ordered pair A comma B belongs to Z, and they satisfy this equation, means 1 less than A minus 3 whole square plus B plus 2 whole square is less than 4 square. So AB are integers, note down, AB are integers. All those ordered pairs with integer components that lie in this annulus. Agreed. That is, S is the set of all ordered pairs with integer components. So the ordered pairs with integer components is called lattice points. So those lattice points you have to find which lie in the region between the two concentric circles C1 and C2. We continue in the next slide. We have this S. Agreed. Now take the first letter Now, how this A will vary in this? How this A will vary? So, the A will vary, A belongs to the integers such that mod of A minus 3 less than 4. That means on the real axis, we mean to say on the x axis, how this A will be there. That means it is all those integers which lie between 3 mod of A minus 3 less than 4. So that it should satisfy. So that is equal to A belongs to Z, and this will be, when simplified, you will get minus 1 less than x less than 7. So that means these are the integers lying between minus 1 and 7, but not minus 1 and 7. Who are they? Who are they? That we will do in the next steps. Right. That is 0, minus 1, 0, 1, 2, 3, 4, 5, 6. Now 3 is the center. 3 is the center of that means the x coordinate of the center of the concentric circles, 3. And these are the points left to 3 and points right to 3. These are the points. Agreed. So now we take A is equal to 0. So A is 1, 2, 3, 4, 5, 6, 7 points are there. So we have taken A is equal to 0. When A is equal to 0, you will get 1 less than A is equal to 0 minus 3 square, that is 9 plus B plus 2 whole square less than 16. But note down, if you take A is equal to 6 also, 1 less than 6 minus 3, that is 3 square, that is 9 only. So you will get the same inequality. A is equal to 6, A is equal to 6 or A is equal to 0, 1 and the same inequality you will get. Now see what are the values of B which satisfy this inequality. So this will imply, so we have subtracted throughout by minus 9. We have subtracted throughout by 9. That means we have added throughout by minus 9. So it will be minus 8, B plus 2 whole square less than 16 minus 9, that is 7. Agreed. So what are those B which satisfy this one? Suppose you take B is equal to, that means, alright, minus 8 less than B plus 2 whole square less than 7. Because B plus 2 whole square is there, it is always non-negative. Therefore, it will not take the values minus 7, minus 6 and all that. It will take only the value 0, the minimum value, 0 less than or equal to, because it is negative, it also takes 0. So 0 less than or equal to B plus 2 whole square less than 7. What are the values of B which satisfies this inequality? So that is B. Suppose you take B is equal to minus 2 plus 2, that is 0 square. So 0 less than or equal to 0 less than 7 satisfies. Minus 2 is satisfied. Minus 1 is satisfied. And B is equal to 0, 2 square, that is equal to 4. 0 less than or equal to 4 less than 7 is also satisfied. So if you take B is equal to minus 3, it is also satisfied. B is equal to minus 4 plus 2. That is equal to minus 2 square, that is 4. 0 less than or equal to 4 less than 7, this is also satisfied. Thus, for these 5 values of B, this inequality is satisfied. But this is satisfied for each of this A. So A is equal to 0, 5 values. For A is equal to 6, 5 values. So what are those ordered pairs A comma B? So A comma B means A is 0 comma B, or A is 6 comma B. They belong to S because they satisfy the inequality. For the what values of B? For these 5 values of B. So these are the 5 values, and for each 0 comma B 5 values, 6 comma B 5 values, the total 5 lattice points will be there in S. So thus we get 10 points of yes. Agreed. The second case, a is equal to 1 and a is equal to 5, like the above. If you put 1, it will be 1 minus 3, that is minus 2 square, that is 4. That is 4. This is 4. 1 less, this is 4. A minus 3 whole square is 4. And if you take 5, a is equal to 5. 5 minus 3, 2. 2 square, that is also 4. So that means the same inequality you will get for a is equal to 1, b is equal to 5, a is equal to 1 or 5. We get this inequality. Now what do we do? Now add throughout by minus 4. We will get minus 3 less than b plus 2 whole square less than 16 minus 4, that is 12. Now b plus 2 whole square, it is because it is a square, it will be non-negative. Therefore, the inequality starts from 0. So this will be 0 less than or equal to b plus 2 whole square less than 12. So now for what values of b, this is satisfied. So for b, minus 4, minus 5, minus 3, minus 2, minus 1, 0 and 1. So for these values of b, this inequality is satisfied. How many are these? These are 7 in number. For a is equal to 1, 7. For a is equal to 5, 7. So the total 14 ordered pairs you will get. So 1 comma b, 5 comma b belongs to S. For b is equal to minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1. Thus we get 14 points. So we go to the next, a is equal to 2. So a is equal to 2 or 4, like the above argument, and this will be 1 less than 1 plus b plus 2 whole square less than 16. Now add throughout by minus 1. We will get 0 less than b plus 2 whole square less than 15. Now b plus 2 whole square is greater than 0. It is giving greater than 0. Therefore, you cannot have 0 less than or equal to. Therefore, 0 is not included in this case. Whereas in the above cases, it is so, because there are negative integers are there. But here, it itself is telling 0 less than. Therefore, 0 is not included. So this will be like this only. For what values of b, this inequality is satisfied. b is equal to minus 5, minus 4, minus 3, minus 1, 0 and 1. So if you put these values, this inequality is satisfied in this. And how many? These are 6 in number. For each a, 6. So there are 2 values of a. Thus you will get total 12 points. So 2 comma b, 4 comma b belongs to S. b is equal to minus 5, minus 4, minus 3, minus 1, 0, 1. These are 5 in number. So 5, and for 2 values of a. So the total you will have. Thus we get 6. Here 6 values plus 6 values. That is 12 points of S you will get. So there is what is left? 0, 6, 1, 5, 2, 4. Therefore 3 is left. That we will do in the next slide. That's what we have the as. A is equal to 3. Now if you put a is equal to 3, this is 0, 3 minus 3, 0, 0 square. So 1 less than 0 plus b plus 2 whole square less than 16. There is no other value. No other value in this case. A is equal to 3 only. In the other cases, we are getting the other values also. Other value also. Now this will imply 1 less than b plus 2 square less than 16. This is 1 is positive number. Therefore, it will start from 1 only. There is no question of taking 0 less than or equal to. If this value is a negative integer, then 0 can be included. But it is not. It is starting from 1. Therefore, it will be like this only. So what are those b values of b which will satisfy this? So suppose you put b is equal to minus 5. Minus 5 plus 2, that is 3 square, 9. 1 less than 9 less than 16. Like that, minus 4, 0 and 1. These are the only 4 points. A is only one point. So therefore, A 3 comma B, A comma B means 3 comma B belongs to S, for B is equal to these 4 values. Thus we get 4 points of S only. Now we will consolidate how many points we got it. Right. So what is S? S is this set. A, B is the set of all ordered pairs A comma B, where A, B are integers, which will satisfy this inequality. And this is the first case. And A is equal to 0 or 6, in which case we get 5 for each, that is 10 points, total 10 points. And A is equal to 1 or 5, we got 7 B's, that we get 14 ordered pairs. And next, A is equal to 2, B is equal to 4, 6 values of B we got, the total ordered pairs will be 12. In the last case, in this case, we got only 4. We got only 4. So they summarize all these things. N of S is equal to, N of this is 10, N of this is 14, N of this is 12, N of this is 4. When added, it is 40. That's what we wanted. So we want to find N of S. That is the question what is asked. So our answer to this question is 40. That is the detailed discussion of the solution of the problem from the section complex analysis, wherein we are asked to find the number of lattice points in the given annulus. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.